Jones here from VIT College Mechanical Department, and I am here to discuss about the experiment refrigeration test on vapor compression. And here are the parts of the experiment. And starting with this is the rotameter, and this is suction pressure gauge, discharge pressure gauge, and this is energy meter for compressor, and this is a temperature indicator, and this is the compressor valve, and this is temperature knob, and this is thermostatic expansion valve, and this is capillary tube, and this is condenser, and this is compressor, and this is evaporator. Now I will be explaining the working principle of this experiment. First we need to switch on the switch, and then coming to this, turn on the compressor valve, then wait for 15 minutes for the steady state to appear, then later take down the suction pressure gauge reading, then discharge pressure gauge reading, and time taken for energy meter to take 10 revolutions, then turning the temperature knob, take down the temperatures till T1, T2, T3, T4 and T5.
Hello, my name is I will be explaining the calculation tabular column of the refrigeration test rig or vapor compression cycle. So this is the tabular column, and the first thing is energy meter reading time for 10 revolutions is equal to T seconds. Then this is the suction pressure P1 in PSI. This is the discharge pressure P2 in PSI. Refrigerant temperature at inlet to compressor, it is taken as T1. Refrigerant temperature at outlet from compressor taken as T2. Refrigerant temperature at outlet from condenser taken as T3. Refrigerant temperature at inlet to evaporator taken as T4. Water temperature in chiller, that is taken as T5. So the time taken for 10 revolutions is 85 seconds, and the suction pressure is 40 psi. Discharge pressure is 220 psi. Refrigerant temperature is at inlet to compressor T1 is 15.2, and the T2 is 90.3 temperature, 90.3 degrees Celsius. T3 is 49.3, and T4 is 6.3, and T5 is 8.6 degrees Celsius. Here we have the nature of graph. This is the nature of graph in TS, which in y-axis we represent it by T, and x-axis we represent it by S. This is the TS diagram, and this is the PH diagram, where y-axis is represented by P and h-axis is represented by H. And here this line we get the condenser temperature and pressure, and this thing is evaporator. Now coming to the work done by compressor, which is represented as W, is equal to number of energy meter revolutions into 3000 T100 divided by time taken for 10 revolutions of energy meter into C, and the number of energy meter revolution is 10, so that is multiplied by 3600, and whole divided by time taken for the 10 revolution is 85 seconds, and C value is 750. So when we calculate this, we'll get 0.5647 kilowatts. Coming next, in case of mass of water in chiller, refrigeration effect, which is represented by N, and the formula is MW, mass of water, into CP, specific heat, into delta T, temperature difference, whole divided by time taken for drop in initial to final temperature, and the SI unit is kilowatts, and the values are MW 11 into CP 4.187 into delta T 8.6, whole divided by 10 into 60. So when we calculate this thing, we'll get the final answer as 0.660 kilowatt. Coming to the next part is COP actual, that is coefficient of the COP stands for coefficient of performance, and that actual COP is calculated by using the formula refrigeration effect, that is denoted by N, divided by work done by compressor, which is denoted by W. Here we have the refrigeration effect value, that is 0.660, and divided by the compressor value, work done by compressor value, 0.5647. So when we divide this, we'll get 1.169. Coming to the next part is theoretical COP, that is coefficient of performance calculated theoretically. Here we have P1, and the pressure P1 when multiplied by 0.68, and when the answer is added by 1.013, we get the pressure in bar, that is 3.733. Next we have to multiply it by 10 to the power of 5 to convert it into pascals, and again we have to multiply the same thing with 10 to the power of minus 6, so that we get the unit in MPa. So when we do this, the final answer we get is 0.3733 MPa. Coming to the P2, the value is 220. You have to do the same thing again, that is multiply by 0.068 plus 1.013, you will get 15.973 bar. And next, if you multiply 10 to the power of 5, you will get it in pascals, and again multiply it with 10 to the power of 6, you will get it, the final answer you will get as 1.5973 MPa. Next, from the pH chart for P1, T1, T2, P2, T3 and T4, when we plot these values in the graph, pH graph, you will get H1 is equal to 395 kilojoule per kg, H2 is equal to 443 kilojoule per kg, H3 is equal to 220 kilojoule per kg, H4 is equal to 210 kilojoule per kg. Theoretical COP, that is theoretically calculating the coefficient of performance. The formula is H1 minus H4 by H2 minus H1, where H1 value is 395 minus H4 210 whole divided by H2 value 443 minus H1 395. You'll get the final answer as 3.854. So this is the pH chart. So here are the values of pressure in in the SI unit following with MPa, and this is the temperature, where we have to find out the T1, T2, T3 and T4. We have to plot it over here, and this thing gives you the enthalpy, that is the values of H1, H2, H3 and H4. So here we have the pressure as P1 value is 0.3733 MPa and P2 value is 1.5973 MPa. So we have to plot it in the y direction. So you will get two values here, this thing, and then you have to take the temperature as T1 15.2, T2 90.3, T3 49.3 and T4 6.3. So the temperature you will get it here as T1, T2, T3, T4. So you will get a quadrilateral. Then you have to plot it downwards, which gives you have to plot it like this, and you will get the four values, which is H1, H2, H3, H4. So using this way, you have to plot the pH graph and get the values of enthalpy.